You may know that it is best practice to use private subnets for your cloud network. But have you actually implemented them? They can be challenging to set up, especially if you have an existing VPC. And using private subnets creates a new dilemma. How do you even connect to these resources? John sometimes complains that Mobycast makes him eat his security broccoli. Well, it's time we add networking cauliflower to the mix to ensure that he and you have a well-balanced cloud-native diet. In this episode of Mobycast, we kick off a 3-part series detailing step-by-step how to incorporate private subnets for your cloud network. After listening to these episodes, you'll be able to set up your VPC like a true networking ninja. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts John Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, John. It's good to be back.
Yeah, good to have you. So we're recording today on the day after Halloween. I don't know if that's I think we've talked about this before, and Chris, it's not a big holiday in your family. Did you do anything yesterday?
You know, my kids are getting a bit older. One is off to college, I think we've mentioned before, and daughter's in high school, so kind of past that age for trick-or-treating. This was, I think, the first year we didn't have a kid go out trick-or-treating, so we just stayed at home, and the doorbell fired like every 30 seconds and drove my dog nuts.
That's fun.
It was a busy night for the dog.
How funny. Yeah. And then, my kids are a little bit younger, so we're kind of in the throes of it. Alana was Harry Potter, and that was pretty cute. Fun that she decided to be Harry and not Hermione, like several of her friends the same age. And then Jonah was Darth Vader, which was awesome because he had like the full helmet, not just a mask.
Nice.
And yeah, it was really good. And the thing is, just because of his 4-year-old proportions, he looked a little bit more like Spaceballs version.
Very big head, Darth Vader. Yes. Head Vader.
So yeah, pretty fun.
Yeah.
Anyway, so we're not doing another episode in a series today. We're starting something new. And so people that are listening, that this is about VPC, so it's an AWS topic. Turn it off if you use Google Cloud or Azure. Please turn it off now. Okay.
Well, not so quick. Not so quick, actually.
No, it's just us now.
Just about everything we talk about today is probably equally applicable to all the cloud providers. And it's actually kind of applicable to on-prem as well. So this is, there are some AWS specific stuff, but also it's really at the core just networking as well, and useful stuff. Right.
And so stick around. And I think when I was first learning AWS, and I think when anybody comes to AWS, and the thing that you go to AWS for usually is not like, I want to go create a big old network and I want to make it fancy. Like, that's not why people sign up for AWS. They sign up for AWS because they want to run some software, typically, or they want to have a database in AWS, typically, right? But then you go and you're going to make your database. And one of the questions that it asks you is, which VPC would you like this in? And then there's like this little default VPC that, names something like AFG123. And you're like, I don't know, I guess. Yeah, that one. And I think for a lot of people, and maybe this is you, but like not you, Chris, but you, the listener, it's like, you kind of put that off, like, let me worry about that later. Or, you realize you can't put it off. So you do a tutorial or something online and you get a VPC set up and you just do it. You follow the steps, but, maybe you haven't really fully understood what you've done. And maybe you've made some selections in the console that, the tutorial told you to do, but you're not sure they're the best way to do it. And you ask around and it turns out that everybody else is in the same boat. Nobody really knows that they did it the best way, except for like a few people that give talks and they say that they work at Netflix. And of course, Netflix did do it the best for Netflix, not for you. So yeah, let's dive into this a little bit and help people sort this out. And I'm not saying that everybody's dumb about VPCs, but they're this big part of AWS, and it's like, it's not really what people arrive there for. So I think there are so many people that try to gloss over it and get to the things that they care about more, like running software or running a database. Wouldn't you say, Chris?
Yeah, absolutely. I mean, we've talked about this so many times where there's just so much to know. There's so much foundational knowledge to just come up to speed on and really have a good understanding of it in order to consume the higher level services. So even something as simple as just consuming an RDS database, you got to know about things like security groups. You got to know about networking, VPCs, subnetting. You need to know about maybe, NACLs. There's just a lot of foundational knowledge there. And so, it's pretty easy to kind of skip, but not have a full understanding of that, right? And have some holes in it. So that's what we're trying to do here, is to kind of help fill in some of those holes. And the spirit behind today's topic is really this concept of, okay, I have a VPC. I understand public facing stuff, and maybe that's kind of like the default way I have my network set up. But, as a best practice, things that need to talk to have the open internet talk to them that are public, those should be on public subnets, but everything else really should be on private subnets, right? That are not publicly accessible. So how do you go about configuring your VPC to have that kind of best practice configuration where you have a combination of private and public subnets? And then once you do that, well, now there's some issues that come up where it becomes less convenient now to connect or interface with those machines that are now private because they're not accessible over the open internet, right? So how do you do that? And so we're gonna explore those options. So we're tackling some topics in VPC, but it's going to be pretty targeted here and really wrapped around that concept of best practice of having a VPC with both public and private subnets, and then establishing a connection to those private machines so that we can do whatever it is that we need to do, whether it be troubleshooting, debugging, maybe some sort of patching or whatever like that. Although we don't like to do that, right? Because servers are like cattle, not pets.
Right. So it sounds like this may be a bit of a Trojan horse, Chris. I thought this was going to be fun networking stuff, and now I'm eating my security broccoli.
I will try to put the chocolate sauce on security topics as much as I can, because as much as we don't like it, or as much as we the concept of it is like, don't want to talk about security. It's so important. So we'll always find ways to sneak that in.
Right on. And yeah, so this is sort of network level security or infrastructure level security where you might have a wide open app and it's not protecting itself, and that whole level of security we're not talking about today, but that app is not even going to be available to the wide internet because it's on a network that isn't.
Exactly. Yeah, so why don't we get started with just like Subnet 101.
Let's do it.
And what that is, right? So we at the very top you have a VPC, it's a virtual private cloud. That you can think of that as your overall network, and then you can divide that network up into subnetworks, right? And that's what a subnet is. So it's a smaller subset of and it's got its own network address space. And when we talk about subnets, we talk about them as being either public or private, right? So public subnets, what distinguishes them from a private subnet is that on a public subnet, there is a route directly to the internet on that subnet through its route table. So it means that machines out on the open internet, they are able to route directly to a machine that is located on that public subnet.
Right.
And vice versa, right? So, and that's really what a public subnet is. A public subnet just means that there is a route to the internet directly for that particular subnet. And so conversely, a private subnet is a subnet that doesn't have a direct route to the internet. So there is nothing in the route table that allows for that connection from the open internet to go directly to a machine that's on that private subnet. In order to enable the reverse direction, so to have machines that are on the private subnet to talk to the internet, we have to do some other things that we'll get into.
Right. And I would say, Chris, that it feels to me like configuring a VPC in the AWS console is kind of analogous to I've got a server room, and I don't know how many computers I'm going to put in it, but I definitely have some routers, and they're all set and ready to go, except they're not configured. And so I'm going to go start configuring routers, and I'm going to say, well, this one configured this way, this one's configured that way. So I'm setting up like the way the network will work, but I'm not putting any computers into the network, which is maybe a little different than, if you've set up a small network before, you kind of do computers first. You kind of set them all up and get them talking to each other and then worry about your router. But it's more routers first. It's more like, let's get into the console, tell AWS how you want the network to be set up, and then you put in computers later. Yeah.
With something like AWS or Google or Azure, you can't do anything until you have a network to put stuff in, right? So you're going to have to, you create that network first. As you mentioned previously, there is a default. You get, when you create an account, you're going to get a default network with just the default settings, and so that you don't have to explicitly
put your production software on it. Default VPC. Let me just use that.
Yeah,
there we go.
It would be
ride the ball.
So it would be interesting to see the statistics for the amount of production workloads out there that are actually running on the default VPC, and I kind of think it's north of 50%.
Yeah, I bet it is. Yeah. So here we go. We're going to change that with one podcast episode.
Absolutely. So maybe just a little bit more about private subnets. So why have them? And it really is like, it's limiting your exposure. So servers or machines or resources that don't need to be directly accessible from the internet, put them on the private subnet so that they can't be. And so you're reducing that surface area of attack. It's just good hygiene. It's good practice. I mean, if you've ever looked at, go ahead, stand up a web server and put it on, put any server, put it on publicly accessible, internet, and look at its logbook. It's like immediately the bots,
they find
the scanner, the port scanners, right? They immediately find it and just start just hitting it and trying to find ways in and vulnerabilities and whatnot. I mean, a lot of those things are not too terribly smart, but still, they're probing. And so, if you don't need that direct connection to the internet, then don't do it.
Yep.
So that's why we have these private subnets, and basically that should be your de facto location for putting resources, is put them on your private subnets, and you need to have a reason why something should go on to a public subnet.
Right.
So we talked about private subnets. So they do need resources that are on these private subnets. They do need to talk to the internet, but we said that they don't have a direct connection to the internet. So how do they do that? And so that's done through something called NAT, which stands for Network Address Translation. Really what that is it ends up becoming a proxy to the internet for the machines that are on that private subnet. So the NAT essentially ends up becoming the public interface for everything behind it. So you have this NAT, this device that's acting as your NAT router that is fronting all of your private network, right? So our private, for this discussion, we say it's fronting the private subnet, and so it hides everything behind it in that private subnet, and as packets go out, it then translates it so that it looks like those packets are coming from the NAT device instead of actually the private. And then when replies come back from the internet, it has some smarts that knows how to do the mapping to say, okay, which one of the private machines should this reply be routed to? Right.
And that's just some Linux magic or some router magic that is able to do that. And I mean, one of the things I remember, Chris, is I think it was 1999. Linux was just out as an open source operating system. It was so new that it was pretty hard to install. Like you would buy a Windows machine and then you would try to install Linux on there. And it was not it was at least a day's worth of effort if you hadn't installed Linux on that particular flavor. So I was sitting in my new job. I was just out of college and I was sitting there trying to install Linux on this machine. And the whole point of what I was doing is I was setting up a network for our little office of this startup company that I was working for. And the computer that I was setting up at that time was going to be the DMZ computer. So it was going to do NAT for the entire office. That was sort of how we set up NAT there. It wasn't something, we didn't have a hardware device for just doing NAT. We just set it up with, putting 2 Ethernet cards into that machine, and one Ethernet card, had a public internet address and the other one had a private one. And I was able to set up routing between the two. And then that was the proxy, that was the NAT. And so I guess ever since then, like that hands-on experience makes it easier for me to think through, what does this mean? Or what I literally, I pictured that computer that didn't even have a case. It was just like sitting on top of a piece of anti-static on the desk next to me. And I had it open because I was swapping out different pieces of hardware. Whatever piece like I couldn't get to work with the Linux operating system, I would swap one out to find one that did have a driver that would work with Linux. So that's why it was open and had no case. Mm-hmm. But yeah, did you learn about NAT in a similar way, just kind of hacking and doing it and setting up a network, or did you kind of come to NAT via the cloud?
So a couple different ways. One, back in the late 90s when I was at Microsoft, we did have the concept of a DMZ for basically pushing content to MSN, to MSN.com. So there was that DMZs doesn't necessarily have to be NAT, right? You can have proxy servers, and sometimes people will use bashed in host to separate these networks, but this concept of something that's separate, have public versus private, right?
Yep.
So there's that, and then, but as far as like NAT goes, I think like that kind of really dove into the details, just setting up a home network with a router, right? So right. I mean, any router you have for your home network, it's going to be doing NAT.
It is.
So you're going to, whether you realize it or not, right? Because it's going to have you'll see things like, okay, what's the WAN address? And then you'll also see like, what's your IP, like what's the IP address range that you want to use, right? So you're specifying like what's basically your public, which is the WAN address that's assigned to you from wherever you're getting your internet access from. And then you're defining the private subnet space essentially by configuring that router to what IP addresses to use. And these routers, they're all going to have defaults too, right? So some, don't really have to get into that yourself, like when you're configuring these things, because it's going to by default use something like 192.168.1.0 or something like that, right?
Yep. That's how you can know how to just go on someone's wireless and go to that and then put in admin password and you're in.
Yes. Admin.
Yeah.
So at any rate, so I think that was my first exposure to NAT, was just setting up a home-based router.
Yeah, that makes sense that it would be there and not at a big giant company like Microsoft where you've got like whole teams that do that stuff for you.
Yeah, absolutely. Yeah.
Cool.
Yeah, and
so we know what it is. We know essentially how it works by having the two different IP addresses and sort of routing between them, just sending everything forward to the private one and receiving everything back and sending it out.
Right. And, the reason why it's called network address translation, is because what that NAT device is doing is it's actually manipulating the IP headers.
Yes.
So the IP headers actually, there's fields in there for the source address, the source port, and then also the destination address and the destination port. And so when you're sending traffic from the private network to the public internet, that NAT device is now changing the source address and source port values to no longer be the private space, but to be the IP address of the NAT device. And so then that gets forwarded on, and then now
it must also get tagged with the actual computer that it came from, right? So if it was like 192.168.1.12, that's gonna probably the NAT computer is gonna remember that.
The NAT device will remember that. So what the NAT device does is it will have an in-memory lookup table that it builds, and so it's going to keep track of these these conversations. And so, and what it does is it uses a combination of IP address and port to uniquely identify responses. So when an outgoing request is initiated, the NAT device is going to say, okay, I know what private IP address you are, and you're going over, say, port 80. It's going to go in there and change that so that now the source IP is itself, and then it may pick up a new port, right? And so that's what it's going to use now to uniquely identify it. So now the port that that is going to be returned back, that it's going to go back to when the reply comes back, it says, oh, this is for my IP address, the NAT device's IP address, right? Because that's all that the public internet knows about. But it's like, oh, and the port is 49,212 or something. Now it goes to its lookup table and says, okay, what is that port mapped to? And then it says, oh, I know that it's actually this is the private IP address that it goes to. And now it knows who to forward it on to.
Pretty sweet. I didn't know the details of that. Very cool.
Yeah. So it has this in-memory lookup table that allows it to know who it should be forwarding these replies on to. And that's why in order for NAT to work, all conversations have to be initiated by the private network.
I think gosh, this is just so interesting, and this is going to be hard to get all this content in, but like a thing that I'm realizing is that I kind of thought that maybe the actual packets would get tagged with something so that they would carry that private computer information with them, but somehow obfuscated. But the fact that they don't feels like a security advantage, right? Even if it was obfuscated, there's nothing about that private network that's traveling with the packets. So that's cool.
Yeah. So it's just abiding by the rules of TCP headers. What we're talking about here too, like this applies specifically to TCP, UDP, and also ICMP, right? Other protocols have to do other things. But because TCP and UDP, they have these source IP, source port, destination IP, destination port as part of their headers, then NAT devices can use that information, right, to do this and to build those lookup tables and just to make NAT work without any modification whatsoever to the devices that are communicating across that, which is a really nice feature, right? So like neither the machine on the private subnet nor the machines on the public open internet know that NAT's happening. It's transparent to them.
Right. Very cool. Yeah. All right. So where do we go from here? We know how it works.
Yeah. And maybe related to this is also kind of like this concept of you now have devices that have multiple IP addresses too, right? So the NAT has a public IP address, right? It has to in order to be that proxy to the open internet, but then it also has to have private IP address as well, right? So because it's on the private network. So how does that happen? And there's many different ways to have multiple IP addresses. We can talk a little bit about we can talk about so when you're dealing with computers on a network, basically there's two types of address. There's a physical address and there's a logical address. The physical address is known as the MAC address, and so it stands for Media Access Control Address. This is the physical address. It's a unique ID. It's assigned to the network interface controller itself, always by the manufacturer. Some devices allow you to actually change it in software afterwards, but for the most part, think of it as like it's kind of like a burned-in physical address, unique ID that's assigned to that network interface card, and that's its MAC address. Yeah. And then you have the logical address, which is the IP address that's now assigned to that. And as part of there's another protocol, it's called Address Resolution Protocol. And basically these are just tables used by the network itself that can map IP addresses to MAC addresses. And so when this is what allows when a packet comes in, because TCP, we're talking about like what's the destination IP address that this thing should go to. When that packet comes into the network uses this address resolution protocol tables to then, given that IP address, what MAC address does this belong to? Right, because at some level, some electronics have to happen that literally switch to, they involve physical things, wires and things like that. Yeah, I mean, I think that it's got to be routed to some physical device, right? So there's a table there that says, okay, given this IP address, what's the MAC address? And So with that, you can actually have multiple IP addresses mapped to the same MAC address.
Okay.
Right. So that's one way to have multiple IP addresses. So so as long as your device supports that, right, and it's making the proper ARP calls to register it, you can have multiple IP addresses for the same MAC address. You can also have multiple network interface controllers in a machine, right? There's, you can have 2, 3, 4, however many network interface controllers your particular piece of hardware can support.
Right.
So there's that.
And I'm thinking back in 1999, that thing that was sitting on my desk on top of a piece of anti-static that I was putting Ethernet cards into. I'm guessing those Ethernet cards didn't support multiple IP addresses. Like those physical cards, or the drivers didn't, or something. But the fact that I had to have 2 of them tells me that there was a limitation there.
Yeah, I mean, so it could have been that. There's also there's the networking considerations of okay, is it actually just are you going to do this at the physical level, or are you going to have more sophisticated software that does the routing to do the networks? Do you going to do
it could have been that too,
and whatnot,
literally
right?
like a cord plugging into something that goes out to the outer wide world internet, and another cord plugging to the next computer on the private network.
Yeah. So anyhow, I just wanted to bring up that concept of IP addresses for machine, and how these machines we're dealing with both these private networks and these public networks. And so any EC2 that we spin up in AWS, and this again goes with Azure and Google as well, it's going to have definitely a private IP address, but then we can also give it a public IP address as well. So it has multiple IP addresses, and you can actually have even more than that, right? So there's with AWS, depending on your instance type, you can have, 8, 16 IP addresses per ENI, and then you can have multiple ENIs per EC2, right? So it's possible that a single EC2 can have, scores of IP addresses that are assigned to it.
Scores. I like it.
Well, I didn't want to say hundreds.
Let's go very analog on this conversation.
Yeah. So it's I need some unit of value here. So pull on my Gettysburg hat and pull out scores.
Yeah.
I mean, it's better than Fortnite, right? Fortnites of IP addresses.
We cover a lot of information here on Mobycast, and if you've ever wanted to go back and remind yourself of something we talked about in a previous episode, it can be hard to search through our website and transcripts to find exactly what you're looking for. Well, now it's a lot easier. All you have to do is go to mobycast.fm/show-notes and sign up. We'll send you our weekly, super detailed outline that we use to actually record the show. A lot of times, this outline contains more information than we get to during our hour on the air. So sign up and get weekly Mobycast cheat sheets to all of our episodes delivered right to your inbox. Okay, so now we have multiple IP addresses. We understand that. And what we're doing here, just everyone listening along, we're kind of going into detail around each, fundamental pillar of networking that you need to understand in order to put together a VPC and use a private subnet with it, and have, workloads running on that private subnet that are safe from the wide world internet.
Right.
So where do we go? Now that we know we can have the multiple IP addresses, we understand how that works, what's next?
Right. So now we have this, we know this best practice. We want to have our VPC set up with private subnets. So let's do that, right? What's stopping us? And so just something to point out now is that once you do start putting your resources onto a private subnet, you have to ask yourself, well, how am I going to connect to that? Right? So right now, if you spin up something on your public subnet, and you need to access that machine remotely, it's going to have a public IP address. You can open up port 22 and a security group assigned to that instance, and now you can just SSH from your laptop at your office, right, into that machine and do whatever it needs to do, like look at a log file or run a software OS update or something like that, right? Pretty straightforward and easy.
And Chris, I think one of the best ways to approach this that'll resonate with a lot of people is just that common early AWS experience where you do create an EC2 and you put the right security group on it. Like I should be able to SSH into this thing. And there it is. It says right there. But for whatever reason, it's timing out on me. I just can't get to it. I think that's something that has happened to so many people. It's definitely happened to me. Has it ever happened to you? Because it feels like the security group is oh gosh, it must have been a security group. Okay, now let me open up the security group to the whole world. There's nothing about the security group now that could possibly be keeping me from this machine. Why can I not get to it? That's definitely happened to me.
Yeah, I mean, this is the fun of network troubleshooting, right? There's like a million things that could be blocking you from that. A typical one would be like, hey, port 22 is just not allowed with the security group that you've assigned to that EC2, right? So you have to ask, is this a...
That's kind of the
network?
First one you learn, right?
Yeah.
Like that's the first thing that happens to people. And then this is number 2. The second thing that happens to them is, okay, I've learned never to do that anymore. I've always got to open the darn port. Shoot, I opened the port and I still can't get to it. And I think this is number 2 because it's unlikely that, other reasons that this could happen would be like, oh, you've got a network access rule or I can't remember what they're called, but they're like network access, like overall rules that say you're not allowed to get to this thing. But like that, you don't get there before you get to the whole, I'm going to put things on a private subnet. Like that's sort of the next level in the Mario Brothers of AWS is starting to put things on private subnets.
Right. Yeah. So we're going to have this issue of like, how do we connect to it? Because and one of the ways you're going to know that you're going to have a problem, right, is like if you're going to go to the AWS console, you're going to go look up this EC2, see what its IP address is. You're going to see, oh, it's like this 10.10.1.13. And now if you do SSH, EC2 user at 10.10.1.13, it's just going to sit there forever, right? It's not going to be able to. There's no route to that. It's not going to be able to connect because that's a private network address space that your laptop just does not. It's just not going to find it. There's nowhere to go. So that's not the IP address that you can use directly in that particular instance. So
now help me out here though, because I was imagining like, okay, so then let me slap a public IP address on it. Oh gosh, I still can't get to it.
You can assign a public IP address to your EC2. So that'll be one of the options that you have when you launch an EC2 is whether or not to assign a public IP address to it. But if you've launched it into a private subnet, right? And if it truly is a private subnet, again, we said a private subnet means that there is no route directly to the internet. Then even though it has a public IP address, there's still no route from your remote machine, from your MacBook, from your desktop, from the office to that machine. Even though it has a public IP address, there's no route to it.
Now I feel seen. This is me. This is what happened to me at least 25, 37 times.
Right. So, just giving yourself a public IP address does not make it publicly accessible, right? You literally have to have the plumbing in place in order for it to make that connection. And this is maybe a subtle point to make as well, but you can have private subnets, machines on the private subnets using public IP address spaces if you really wanted to. You shouldn't do that.
Oh yeah.
But there's nothing preventing you from doing that. Again, especially with NAT, and I mean NAT is hiding that whole address space. So if you wanted to, you could use,
whatever.
Just pick whatever address space you want, right?
Yeah.
It doesn't really matter.
The private address is not being allowed to be on the open internet, like from the point of view of internet service providers, is not a convention. But once you're in your own home network, it's it's like really all about like helping you realize, oh, that's a private address.
One of the really great things about NAT is it extends in a way the IPv4 address space.
Sure does.
It's been one of the saving graces actually, right? Because almost
I'm
everyone
never going to learn IPv6. Forget it.
Yeah. I mean, almost everyone is still on V4. V4, 32 bits, gives us theoretically, a little more than 4 billion IP addresses. And in practicality, because of the way that CIDR works, it's actually less than that. It's somewhere around 3 billion or so. So 3 billion IP addresses, like, that's not a lot. right? Given like how many devices that we have. I mean, there's more like smartphones, I think, right now than that. So
right.
Definitely have more devices than that. And so the NAT allows us to live with that limitation, right? Because we can have we only need one IP address, and we could have thousands of machines behind that in a whole nother address, in duplicated address spaces. But that's all hidden, right? Because it's this private network. And so NAT really deals with this concept of IP address exhaustion, because it is so limited, right? And so this is what, actually internet service providers will sometimes do as well. I know, talking with some of the team members that are down in Argentina, some of the service providers they have down there, they have IP addresses, or public IP addresses are very scarce, and they don't have that many of them that have been allocated to them. So what they do is they use NAT with their internet connections. So they...
I would not be happy about that.
Yeah. Well, they don't have a choice.
Right.
This is, but the truth is like without NAT, then they probably wouldn't have internet access, right? Or it'd be super expensive. Yeah. Right. So it really deals with this problem of like, hey, we don't have a lot of IP addresses to deal with here. So what do we do until we all switch over to IPv6, which, is trillions.
That's going to take 7 episodes of Mobycast.
Yeah. Cool. So we've talked about this concept of, okay, private subnets are good. We want to do it, but like, how do we connect to them? And so really it kind of boils down to like, you can think of this as there's 3 main solutions to this. So you have like a physical solution, you have a virtual solution, and then you have there's this other one that's, we'll call it like a leapfrog solution, right? So the physical solution is I have a direct network connection from where I am into my private network, right? And that is separate. Only the people that should be using that can, and it's secure. And so that's one way of doing this. So AWS, they have direct connect, right? That's their technology for basically giving you this network pipe that is private, and it's direct from your remote location into your VPC, right?
And it can go all the way into a private subnet of a VPC?
It will go into your VPC. And then from there, you can set up the route tables accordingly.
Okay.
Right.
Okay.
So just with our route tables, we usually set it up such that any subnet within our VPC can talk to any other subnet inside our VPC.
Okay.
And that's all just with our route tables.
Cool.
So, this is a fine solution. However, there are definitely some downsides.
One thing I've never known about Direct Connect since I've never used it, but it just comes up and up and up and up with enterprise type folks. Is that a machine? Do they ship you a machine? Like, what is that? Or is it like a guy or, what is it?
It's a network leprechaun. So yeah, what is it? Great question. So Direct Connect, what it requires is you're going to be dealing with some network provider that has worked with AWS that provides that direct connection into AWS's backbone, essentially, right? So typically this means you need to make you're provisioning a circuit essentially with one of these partners, typically somewhere very near to where your machines are located, whether you're like co-hosted or wherever you're co-located, whatnot. And on your side of it, you need to have a network device, right? So you're going to have a router, a switch, and as part of setting up the Direct Connect, you'll be updating the configuration of that so that it knows how to talk to the other end of that circuit that is now inside the AWS backbone going into your VPC. So on the AWS side, they're setting up that end of the connection and the networking and the endpoint that's going to happen. And then on your side, you're dealing with someone that's giving you an actual physical connection and the routing necessary to get to that. And you have to have that physical network device to do that configuration. So
cool, makes sense.
So these are some of the cons, right? Like this is expensive. It's requiring dedicated hardware on your side, and this only applies if you have an actual physical location that needs to be connected to your VPC, right? So you're not going to get direct connect for your laptop, right?
Right.
It's not going to work. That would be an example of a physical solution to how to talk to our private subnets. Another possible solution is a bastion host or a jump host or a jump box. And this is what I was talking about, like a leapfrog solution. So really what this is that concept of you first connect to a machine that is publicly accessible. And then from there, from that machine, you can now jump to the private machines, because that particular that bastion host, has access to both the public internet as well as to the private machines, right? So typically what this is your bastion host. It's a public facing server that's running the SSH daemon, so you can shell into it. And then once you do SSH into it, you now can do another SSH session to go to something on the private subnet, because that machine, it's inside your VPC now, right? So it has access to that.
That bastion host, I imagine if you went on there and you did something like a netstat, you would see a couple of ETH, like ETH0 and ETH1, and the ETH0 would have the public IP address and the ETH1 would have the private IP address. Like you'd be able to see, oh yeah, look, this is on both networks.
Yeah, and that's true for any EC2, right? It doesn't have to be a bastion host. It could be anyone. So
Sure.
They're all, like, as we talk about, all of these were set up that way. So if it has a public IP address assigned to it, they always have a private IP address, right? So anything that has a public IP, you're definitely going to see multiple, and chances are with AWS and with EC2s, there's probably multiple IPs, regardless of whether or not you even have a public IP. I wouldn't be surprised.
Right. So then this bastion host also, you might be able to look at the route table on that host itself and see that it has like a route out to the internet and a route into the subnet, the private subnet.
Yeah. So so the bastion host, so it has to be on a public subnet, right? Because you need to be able to connect to this over the public internet. So it's going to be on a public subnet, which means that the route table for that subnet is going to have a route for talking to both machines that are on the private subnets as well as a route out to the internet. And so typically with like AWS, the way that we do that, right, we're going through an internet gateway. So there'll be a route there for that public subnet that says, okay, if it's anything that's not internal, everything else, the catch-all, that's going to get routed to the internet gateway. And then the internet gateway will then get it in and out. So that bastion host is on a public subnet. And so that's how it has this public access. And so if you were to look at the routing on that machine, that's what you would see, that there'd be routes for internal, the private subnets, and then you'd also see a route that shows it's going through the internet gateway to do everything else.
Perfect. Cool.
And there's nothing really special about a bastion host, right? Literally all it is just a server that's on a public subnet that's running SSH, and that's it, right? It's just how you use it. The advantage of this, right, is that you're minimizing the surface area to be protected. So instead of having SSH access, you can put these other things on the private subnets. They don't have to be on the public subnet. You don't have to manage this large surface area of machines that can be accessed from the open internet. You should have rules that say only allow SSH traffic from this IP range from the internet.
Yep.
Right. So find out what your remote locations are and have rules in there, as opposed to just letting any traffic from anywhere in the internet come in on port 22 on the SSH. So it minimizes that surface area. It does allow you to have your machines on the private subnets that you want to connect to. But obviously some cons here. There is this extra layer of indirection that you have to deal with, right? So it's just another hop to go through, and it's not just from a performance standpoint. It's also just from an actual usability standpoint, right? So like I have to, if I want to SSH into a private machine, I first have to do an SSH session into the Bastion host. And then after that, once I'm on the Bastion host, I now have to do another SSH session into the machine that I want to access. So there's that extra layer of indirection. Another thing that is a management complexity is that SSH keys and how those need to be managed. So for each one of those machines that you want to connect to on the private networks, you're still going to need SSH keys. So how do you manage that? Where do those keys reside? I mean, it's not great to just copy those machines and leave them permanently on the Bastion host, because then you're kind of defeating the purpose a bit, right? Because now it means anyone that can get into the Bastion host, they have
right.
keys to the kingdom, right? And they can go access any other machine. So there's that complication. It's also a single point of failure, right? Typically, so you can have multiple. I guess you can have multiple Bastion hosts, but how do you can't necessarily put a load balancer in front of it because it's SSH typically, right? So it's a single point of failure. And then, as we talked about, there's this just the security risk of protecting that Bastion host. It becomes a pretty key, critical potential hole in your perimeter.
It's funny because it's like the easiest way in some ways. Like, oh yeah, just throw up this machine and then connect to it, and then you've got your access to your private subnet. And so it's in some cases it may be the first thought, like, oh, okay, I could just do this, and then I don't have to worry about setting up something complicated. But it's not. It ends up being, over time, the amount of time you spend messing around with that stupid Bastion host or hosts just eats into your day and your soul.
Yeah, absolutely. Yeah. Yes, it is. So, and it's a good point to say, like, for completeness, we're mentioning these solutions, but it's not really a great solution, right? So Bastion host, definitely something a bit more of a legacy solution. There may be circumstances where it makes sense for you, but for the most part, you should be looking at other things. And so maybe that's a good lead into the third category of solutions, which is the virtual one. And that is basically virtual private networks, VPNs. And so this is another way of getting that secure connection to my private VPC, but to do it over the internet, right? By creating this tunnel that's secure and encrypted and end to end. So VPN is that virtual solution, and it's definitely a good option here, right? Because it's balancing out. It doesn't have to be expensive. It doesn't require any dedicated equipment. It can, but it doesn't have to. Right. So there's many different options here for VPNs, and like ranging in the cost and the equipment requirements. And the other thing with VPNs is they're good for both connecting an on-prem location to your VPC as well as just doing general remote user access, right? So this is you're at the coffee shop on your MacBook working away and you need to connect into your VPC, right? You're not at an on-prem location. There is no hardware or anything like that, and you just need to be able to access it securely. So VPN gives you a solution there as well.
That's right.
Yeah. So there is, again, lots of options here just in the AWS world. So some of the options include there's managed VPN, which that requires a network component on your side. So it's really for on-prem to VPC connectivity. There's VPN Cloud Hub, which again is kind of dealing more towards on-prem and being able to connect multiple on-prems together by using your VPC as a hub. And another category is just third-party software VPN solutions. This is kind of interesting for me. So just maybe a little bit of a detour story time. So I was preparing for this episode, going and researched it, making sure that it was using the right terminology that AWS is using and whatnot. And I have done a lot of just using of VPCs and networks and VPNs, and kind of really understood like what the options were. I've studied for exams and really kind of feel like I know a lot of this material pretty well. And as I was looking at the specific VPN options, I came across a page on AWS where it was like, oh, there's site-to-site VPN, there's client VPN, there's VPN Cloud Hub, right? And there's third party. I'm like, site-to-site VPN and client VPN, what is that? That sounds new. And so it was one of these things where it blew my mind a little bit that, again, that rate of innovation that's happening is so rapid. It's like, I completely missed this, so it used to be called managed VPN, and that was where you had this dedicated piece of hardware that's at your on-prem site connecting in your VPC.
Okay.
And that's now been called site-to-site VPN.
Okay.
And they have this other option now called client VPN, and client VPN is the software-only solution, no hardware necessary. And so this is the one that's going to work for your general remote user access. It was just so surprising to me to come across this because I just had not seen any mention of it whatsoever. All like exams that I'd taken and studied for, it was never mentioned. And it's like one of those, it's such a big new feature that it just took me off guard, right? To find out that this existed, especially because I didn't really see that this existed until after I went through the process of figuring out how to go set up a software VPN, and it ended up being quite a bit of work. And that's what we're going to talk about more as we go through this is like, okay, we want to go with a software VPN solution. Okay, how do we do that? Let's go see what the choices are. And now we have to go implement that. And so I went through that whole process. And as I was kind of dotting I's, crossing T's, doing some final research, I come across this AWS client VPN, and I'm like, oh my goodness. Like,
oh man.
This is the AWS managed way of setting up this software only VPN. And there's some really, really great things about it that make it super easy and quick to set up. It does have some limitations that are not so nice as well. So I think this is something just completely for a future episode to go dive deep on just client VPN, and how do you go set up a software only VPN using this, and just what are some of those trade-offs that it makes. But again, I was really surprised to see that like this is, I had no idea that this was even an option, and it was released in December of 2018. That's really recent. Yeah.
Mm-hmm. Yeah. Well, so all of this is such a good teaser for a future episode, because that's exactly where we are right now. We're at the end of the limits of my, and I imagine my attention span matches or is a little bit smaller than you, our listener. So here we are at the end of it. We're going to have to save everything else for next week. What do you think, Chris?
I think absolutely. There's a lot to cover here, and I think this is a good point to stop. We've covered this whole concept of VPC and splitting it out into into public subnets, into private subnets. We kind of went deep into NAT and really understanding like what's happening there, and with IP address spaces. We've talked about networking, like how you can have multiple IP addresses assigned to a same machine, so you can be these machines that are in between that can be on both have access to both public and private networks. And we've talked about, okay, how do you connect to these things that once you do put them on these private networks, how do you connect them? Because it gets to be a bit trickier. And we've gone through all the options. We've said, hey, VPN is a really good way to go. Next time we can kind of talk about, okay, now that we've decided we want a VPN, what are our options there? And spoiler alert, or maybe not so much of a spoiler alert, we're going to go with the software only solution. So we're going to walk through that. And then once we have our VPN set up, we're now ready to go, right? We can now start creating our private subnets, and we'll just walk through that. Like what does it mean to create a private subnet and set up NAT for that, and then be able to VPN into one of these private machines?
Right on. Well, I'm looking forward to that, Chris. Thanks so much for today's stuff too. And I want to say something real quick. We got a comment today on Reddit, and it was so fun to get it. And it was funny. One thing that was funny about it is that it talked about, the guy that asked the question seems to have done that before. And it's like, that's us. We're here. We are literally here on Reddit, and you can talk directly to us. We're not these people that are like talking heads. We're actual people that will answer your questions. So come ask us questions. And I will answer them in sort of a lighthearted way, and Chris will answer them in a very deep and technical way. All right. So thanks so much, Chris. And we're looking forward to talking again next week.
All right. I'll talk to you then, John.
Okay. Bye.
I swear I knew it was his woman.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/mobycast.
It knows my faith. It knows my secrets. Gets inside your head. It shows you.